Now we come to the next important method of integration, that is called as integration using partial fractions. Now this is used to integrate the functions of the type f of x upon g of x, where f of x and g of x are the polynomials in x. So this type of function is called as a rational algebraic function. The high level procedure to solve this kind of integrations is mentioned here. That is, firstly we convert the given rational algebraic function in proper form if not in that form already. So by proper form what we mean is the degree of numerator, that is f of x, should be strictly less than the degree of denominator, that is g of x. So if it is not so, that means if the degree of f of x is either greater than or equal to g of x, then first of all we do the straight division, and then in the resulting expression we will get the algebraic function in proper form. Otherwise it is called as improper form. So after doing that, secondly we try to factorize the denominator, which is g of x, into the different linear factors. Next we try to express the rational function as the sum of multiple partial fractions, as we will see ahead in the further cases. And lastly we integrate that each term using the standard results. So the last step is the straightforward, which is based on the already known formulae. Now let us see the different cases which are possible inside this particular method. Now the first case is that of the linear and non-repeated factors. So by this we mean in the denominator, when we factorize, as we have seen earlier, so after factorization we get all the linear factors and each is non-repeated, that means each factor appears only once. So as an example, let us take the first term shown here, that is, it is a rational function of the form px plus q upon x plus a into x plus b. So you see now it is in proper form because the numerator is a linear expression, that is first degree expression, and denominator is a quadratic expression, that is second degree, and the denominator is factorized into two linear factors which are not repeated. Now if we recollect, the next step was to express this function as the sum of two individual fractions. Now in these fractions the denominators will be nothing but the two individual factors that we found out of the denominator, and in the numerator of these two fractions there will be unknown constants that we have to determine, isn't it? So there must be some a and some b in the numerator, uppercase, that we have to decide. So if we can write the given function into this form, then the right hand side is very easy to integrate because those are simple standard integrals, right? And similarly, suppose instead of two factors in the denominator, if we have three factors, so that in general we consider a quadratic expression upon a cubic expression, which makes it in proper form, we can break it into its partial fractions as capital A upon x plus a plus capital B upon x plus b plus capital C upon x plus c. So all the numerators are precisely the constants that we have to determine. Now the next question is, how do we determine this capital A and capital B? So for that what do we do is, if we cross multiply and write the numerators, we will get a into x plus b plus b into x plus a. This is the numerator on the right hand side. Now the same numerator must be equal to the numerator which is on the left hand side. So therefore we must have px plus q on the left hand side, right? Now to get the value of a, what do we do is, we make the other term vanish, right? And to do that we can put the value of x as minus a. That is because the expression that we have got, this particular equation, is an identity in x. So we are free to put any value of x and this particular equation will always hold true, right? So putting x as minus a, we see that the second term basically vanishes. So therefore that gives us the value of a. And similarly, if we put x as minus b, the first term will vanish and we will get the value of b, isn't it? So that is a way to get a and b. Now a shortcut to obtain capital A is nothing but we observe what value of x we should put to vanish that particular denominator, and the answer is we have to put x as minus a, isn't it? So with this value, what do we do is, in the left hand side expression, that is in the original expression, if we temporarily ignore the factor which gives us x as minus a, then in the remaining expression we have to put x as minus a, and that is nothing but the value of capital A that we are trying to find out, because that is what we get by the cross multiplication and substituting x equal to minus a. Right? So that is a way to get the constants. Now let us solve one question based on this so that this procedure will be clear. Here we have to evaluate the integral of x plus 2 upon x square minus 3x plus 2. Now looking at this, we can readily factorize the denominator, and we see that that is nothing but x minus 1 into x minus 2. Right? So we see that we have two linear and non-repeated factors in the denominator. So we say that let x plus 2 upon x minus 1 into x minus 2 is equal to a upon x minus 1 plus b upon x minus 2. Right? So as we have seen, to get the value of a, make its denominator 0, that is we have to put x as 1. Now where do we have to put x as 1? In the expression other than x minus 1. So therefore we get a as 1 plus 2 upon 1 minus 2, isn't it? So that gives us minus 3. Now to get b, we have to make its denominator 0, so that means we have to put x as 2. And where do we have to put x as 2? That is in the expression on left hand side, excluding the factor which is the denominator of b. So therefore after putting x as 2, we get b as 2 plus 2 upon 2 minus 1. Right? So that is nothing but 2 plus 2 is 4 upon 1 is 4. So a is minus 3 and b is 4. So therefore our given integral can now be written as a was minus 3 upon x minus 1 plus 4 upon x minus 2. So basically we have to integrate these two terms, and these are the simple direct integrals, that is minus 3 into integral of 1 upon x minus 1 is log of x minus 1 plus 4 into, now integral of 1 upon x minus 2 is once again the log term, that is log of x minus 2 plus c. So this is the way we evaluate the integral using partial fractions for the first case, that is linear and non-repeated factors.